There was a really nice quote that I came across, which is that almost no prerequisite to any major invention was made with that invention in mind. Can you imagine a point in the future where you are letting agents loose in these environments without specifying an objective for them?
I think we as humans, we kind of decide what's interesting. I think there is even an example where the entire evolution of mathematics was guided by people deciding what's next, what's interesting, what's not interesting. And just the problem being hard doesn't mean that it's interesting at all, right?
I believe very strongly that we need simulation. And I also believe very strongly that we won't be able to build a simulator of the real world any other way. So when you combine those two things, I think, yes, it is a big step for my version of AGI.
Welcome back to Google DeepMind, the podcast. I'm Professor Hannah Fry. Now, the latest video generation models have impressed the entire world. They've created this near-perfect imitation of reality. But the limitations of video is that you are just a viewer rather than a participant. And that's not how humans experience the real world, right? We instead can navigate environments we've never been to and still have an expectation of what we're likely to encounter. We can explore in every feasible direction, kind of without limits, and interact with things that we chance upon along the way. And that is the next great frontier for this technology, to move beyond generating a perfect recording of a scene and towards building a dynamic simulation of a world we can finally step into. Enter Genie 3, a prototype world model that can generate an unprecedented variety of interactive environments. It's already been described as a stepping stone towards AGI. And with me today are two of its creators, Shlomi Fruchter, Research Director, and Jack Parker-Holder, Research Scientist. Welcome to the podcast, both of you. Can you sum this up in a sentence for me? What is Genie 3?
It's a real-time interactive world model that allows you to create diverse, visually interesting worlds from a text prompt. So there is no underlying game engine, no structure, no code. It's just a neural network that's predicting every single pixel in reaction to inputs from the user and also the past. And so the flexibility and the diversity of things you can create in basically no time is quite unprecedented.
You haven't had a whole army of artists sitting in rooms constructing a world in order to be able to interact.
Yes, I think the point is that you can create any world that you can imagine, right? And that's not something that you can do with a game engine, right?
Okay, let's have a look at it, because you've got some demos for me, right?
Yeah, so we have a few. The first one, I think you might like it. So it's basically playing a cat.
Okay.
So a
You've got me
ginger
already.
cat, not so.
Excellent.
Let me run it now. We basically prompted it with being a cat.
So this is reacting to the inputs that you're giving it.
Yes, exactly.
Is the light going to change as you go into the... Oh, look at that. Look at that.
Yes. So the model is basically trying to predict what's going to happen next based on the sequence of inputs that it gets, and it does it in real time.
So looking at this superficially, I mean, this doesn't look that different from if I just loaded up a video game, right? How is it different?
Oh, I think the key difference is that this is generated from text. So every single pixel is generated from a model, right? Which is just predicting the pixels.
I mean, there's also sort of the detail that you're seeing in this 3D environment. It's also quite reminiscent of some of the stuff that we're seeing with Veo. Like,
Yes.
if I didn't know that you were interacting with it, how is it different from that?
So when you create a video using Veo, so you provide a prompt, and then the model is trying to figure out how to create this entire video of, say, 8 seconds, kind of like from start to finish. And once it's ready, then you cannot change how the camera moves around, and definitely you cannot explore it much more than just 8 seconds, right?
Can you use an image to prompt this, or is it only text?
Yeah, so we just found out that we can actually use an image and the videos to prompt them all. And in this particular case, we found that we can actually use paintings. For example, this is Nighthawk by Edward Hopper.
A very famous picture.
Very famous picture, and from 1942. And yeah, basically we asked Genie 3 to let us walk into the painting.
So this painting is of a very vivid image, a street corner, at nighttime. You're looking in through the glass to see a man and a woman leaning up against a bar, and then someone serving drinks the other side of the counter. It's got these like rich greens, the pavement underneath, the way the light falls is really, really evocative. But now that you're navigating this space and turning around, I mean, this is really extraordinary. It's like you've imagined what would be on either side. Can you go around the back of the man and the woman? I want to see the back of their heads. And you can. So it's like got all dimensions of the original painting. Let's turn around and see the rest of the street as well. And in the distance, you can see these street lights just pinging off into the distance as the road extends. Some billboards above other shops and establishments off into the distance. And now we're looking back. We've chosen to sort of look back at the image of the original painting to see it there. That is really amazing. It's all consistent, all completely consistent. Have you got another one for us?
Yeah, we have one that we're just kind of controlling the jet ski around a few islands. So let's see how it goes.
Tell me the original prompt.
So it's sailing a jet ski through the waters around the islands of Kauai.
Ooh, sounds dreamy.
The waters have different ramps that we can go up on. Yeah.
Okay.
Let's see.
All right, here we go. Okay, so we are sort of the POV of the person on the jet ski. We can see the hands in frame. Both hands are consistent with each other, I should add. The water is beautifully still. You can see these islands in the background. The sun is quite low in the sky, and you can see the reflection of its rays on the water. Now I see you're taking us up a ramp here.
Trying. I'm a bit too slow. I don't know.
What's it going to do on the way down? I mean, and it splashes when it hits the water.
Let's look back.
And when you look round to the back, there's a trail in the water, exactly as you would expect from a real jet ski. So are you seeing elements of where it's understanding physics?
Definitely, yes. Like there's some things we, I guess, refer to them as emergent properties, where just from having sort of general training and seeing lots of different things, when it sees a new scenario, it understands sort of like how smoke moves or how water should flow. But that's not maybe 100% accurate in every single setting, but it's got enough accuracy that you do feel some sense of being in the scene. And as humans, we can't obviously spot these things that are wrong with it.
So I think, as Jack said, like there are definitely limitations. But on the other end, I've been working on game engines in the past, and I think we worked really hard to make all of these kind of like effects independently, like the lens flare and the water simulation, everything. And here we have basically a model that can do all of that out of the box, with some limitations, of course. Yeah.
Without even really trying.
And there's other things it can do that would be almost impossible to get through other methods, right? Like simulating other animals and people in the world. I think that's something that's really exciting more in the future as well, is be able to interact with other agents in the worlds.
Yeah. I mean, this totally interactive environment that ends up being consistent regardless of which direction you push it in. I mean, that's really extraordinary. I mean, these demos kind of demonstrate the proof of concept, I guess. But how would you see this being used? What are the kind of applications that you'd be looking at?
One thing that we are very excited about is using it for actually the simulation environment for agents. So, for example, you can imagine an agent that wants to accomplish a goal, right? And then we can put them in any environment that we can imagine, maybe one that is more challenging for it, and then it can explore the environment, maybe try and accomplish a goal and learn from its mistakes, again, not without doing anything in the real world, which is very expensive. Another thing is that we're excited about is actually using those simulations for planning. So if you have a robot or you have an agent that wants to accomplish a goal, they can maybe do some rollouts in this simulation, figure out what might happen. For example, if they want to go across the road, and the agent can use the model to predict a few options. Maybe there is like a few scenarios. Maybe a person going to cross its path, maybe something else going to happen. And then using those rollouts, it can decide what's the next action it should take. And then this is used for planning. And beyond that, we just see a lot of applications for education, for entertainment.
Just anchor this in a few examples for me. So, I mean, what's the idea here? Are you going to, in a history lesson, be able to create a world of Victorian England, for instance?
Exactly, yeah. So imagine you are in front of a bunch of students. You know, they're obviously excited to learn about Victorian England, but they've also got a lot of other distractions, things that they're interested in as well. Instead of just reading a textbook, you can instead allow them to kind of step into the world, right? And you can take them on a virtual tour, in a sense, of what it would have been like to be there. So for places that maybe harder to access, maybe far distant corners of the planet, or perspectives that you couldn't otherwise get. So being a jaguar, for example, or other kind of animals, or being a shark, or going back in the past. These are things that you couldn't really get any other way as an experience. And it might make more visual learners in particular, I think, resonate more with them.
And that's when you have the human who's playing with the controls. But as you say, if you then let an agent loose in this, that opens up a whole nother level of possibilities.
Yeah. So an agent basically, again, once you have a real or very close to real simulation of an environment, then the agent can use it instead of actually learning in the real world, which is very costly, right? If an agent makes a mistake, or if a robot makes a mistake in the real world, it's much harder to kind of like fix. And basically, this is a way for agents to learn in a simulated environment where we can control everything. We can set up some environment that is maybe more challenging or less predictable than what typically the agent was trained to do, and this way, basically, the agent can improve in this safe simulation. So we're very excited about that. Yeah.
So let's say that you were maybe running a factory and you wanted to install a robot with a particular task. You can recreate the precise environment it will find itself in and allow it to, find its own mistakes.
Yeah, I mean, it's a great example because this is already something that we're close to be able to do, like already, right? Robots are getting quite capable. But I think what's even more exciting is things that it's quite far away from being able to do, that this could completely enable and unlock. So having robots and embodied agents like actually in the real world, right? The diversity of possible scenarios is just quite hard to fathom, I think, for our current systems. I think of this example of like, what would an embodied agent do on Halloween, right? It's maybe one day a year it sees children running around in costumes. Like, what would it do the first time it sees this? It's quite a challenging scenario to prepare for, right? And even if you've seen it before, it might be different in the next year. And so to really be able to simulate these rare events, right, and be able with text describe any imaginable world, to become robust to it, make sure the robots are safe or the agents are safe. They understand all these different things, but they can also learn from their experience as well, which we know is really important.
But then I also wonder, I mean, all the examples that we've given so far has been at sort of experiencing the real world at the human level, as it were, in terms of our size. Could you kind of shrink this down and create a simulated world that was at the level of molecules or the human cell, for instance?
Yeah, so we tried that, and we actually have a few examples where you're like moving around like a blood vessel. It's not necessarily always biologically accurate, but this is not, we don't think it's a fundamental limitation. Like we could probably, if we had more kind of like accurate simulations that models can be trained on, then we see that in the future maybe we have other variants of models that are able to kind of specialize in this particular environment. But we did try to focus more on the real world, kind of like the world from the eyes of a person, because we think that's the kind of the most widely applicable in terms of the generality of the model.
Is this about just utilizing the existing developments in artificial intelligence, or is this also about kind of stepping us closer towards the goal of AGI?
We think this is definitely a kind of a new kind of foundation model, and that's why the breadth of applications is so sort of so wide, but also so nascent, because we've never really had this kind of model before, right? It sort of blends and combines ideas from what we've seen in language models and also video models, right, with some of the techniques that we use. And so it's kind of combining these different elements in something quite new, right, which I think is what's so exciting about it, right? And this breakthrough that we've made is that it might enable some completely new applications that we didn't really have before. And so it's still quite an early stage for this research, but we're quite excited to see what the next few months bring.
Well, let me dig into that a bit deeper then, because I know that your background is much more in Veo and the video side of things.
Yeah.
But you were working on Genie 1 and Genie 2 before you and your team came on board. What were you doing there? What was the inspiration, and how is it different from this iteration?
So before Genie, I was working on open-ended learning, so training agents in large simulated environments where we could configure different components of the world. So we worked on the XLAN project, and the idea there was to basically, with procedural generation, generate wide variety of environments that were still specified in code, and have the agent learn from these different experiences and to become a generalist agent in simulation. But ultimately, we were bottlenecked by the availability of environments. Were also, my PhD, working a bit on world models as well, but with a much more limited constrained setting. We were training world models from single environments, typically quite low-dimensional ones. And the dream was really to combine these ideas, to learn general world models that could be used simulators for any imaginable tasks, and then train agents in them to solve completely new things and have this kind of open-ended loop where we'd generate new worlds and the agents would learn from those. We started with Genie 1 as kind of a proof of concept, like, could we do this at all? Could we generate new worlds that were interactive at all, right? And that was quite a major breakthrough. And then with Genie 2, we scaled this to any 3D sort of environment.
There were some things that emerged from emergent properties in that work. Tell me a little bit about those. Were they expected?
So for Genie 2, the question for us was, can this idea scale, right? Because Genie 1 was quite a simple proof of concept, right? It was, does this work at all? Whereas Genie 2 was like, is this something that could really scale to look more like what we see in foundation models nowadays? And we weren't sure if it would really work, right? We weren't sure if it would be consistent for very long because Genie 1 only lasted a couple of seconds. We weren't sure if it would work at higher resolution because Genie 1 was 90p, which is very small images. Genie 2 was 360p. And then the time diversity of environments was a significant increase. And so given all of that, we weren't sure if it'd be possible to have a single neural network that could simulate anything within that domain. And so when we actually got the model, it was definitely an emergent property that for completely new worlds, and we used Imagine 3 to generate the starting frames back then. It could do things like simulate smoke, or when you drove off the side of a cliff, the car would have gravity, or if you landed in a puddle, it splashed. And it was quite surprising that this worked so well, and that gave us the confidence that this next step with Genie 3 would be possible.
So Genie 1, 2D.
Yep.
Genie 2, 3D. So with Genie 1 then, you're like, right, we want to be able to create any sort of environment, and you feed in, I mean, it was platform games, wasn't it? Just tons and tons and tons and tons of footage of platform games.
Exactly, yeah.
And then were there any emergent properties in that?
Well, the fact that you could generate completely new ones, I think, was surprising. I don't think that had really been shown before.
Even a painting, right?
Yes,
like
actually. Yeah, I mean, you know the work better than me. We even had a picture of my dog in the park, and you could kind of move her left and right like a platform game. But of course, she's not one. We also had Jeff Kloom was an advisor of the project. His children did a bunch of drawings, and we were able to kind of animate those and move them around like games. I think it's safe to say that was not in the training data, right? So I'm happy to call that an emergent property. It looked quite different to what it was trained on. And thanks, Shlomi, for reminding me, because it's been a couple of years.
And then the step between Genie 1 and Genie 2 was making it 3D.
Yeah, so it was increasing the diversity of the things it could do. So compared to Genie 1, which was just 2D platform games, it was 2D games, but as well as 3D environments as well in the same model. It was also higher resolution, and there was a lot more consistency, so it would last a bit longer when you interacted with it. So it was really a step up in capability in a few different dimensions, which required a much more concentrated effort to get that to be possible. And we weren't sure if it would actually work at all. So it was more of a proof of concept at the slightly larger scale. And that gave us confidence that what we have now would be achievable.
So you were working on building an environment that you could interact with.
Yep.
And meanwhile, in parallel, you were working on video generation.
Yes. So my background is actually in 3D game engines, and but very long time ago, I used to work on simulations, and that was kind of like where I started working on AI. Back then, we didn't use even AI; we call it ML. But in the last few years, I really got more excited as the technology evolved, and then worked on image models, video models, and in the last years, video models, as we all know, got to new levels of realism. And I remember looking at one of I think it was the Imagine video models, and just saying how is it possible that there is a full simulation of a world just like in this model? It's mind-blowing, right? If you think about the level of realism that those models even initially achieved compared to simulation using 3D graphics methods. And then with Veo, what we tried to do is basically to build the best possible video model. And when I saw the results, I started thinking, okay, what happens can we do that in real time? And then I was obviously following the work by Jack and team, and I think that was also very inspiring. And we just said, okay, we have to go to the next level.
So what were the elements from Veo that you wanted to combine or learn from for this project? Because it's not just the visual aesthetic.
The quality and the realism is very something that we really invested in. And I think there is a level of realism where I think we kind of got to it with Veo 2, that the physics are not perfect, but it's good enough to start to be useful, right? So we can actually create some scenes that are indistinguishable from real footage, right? Not everything, not all the time, but it's starting to be there, right? With Veo 3, we also added audio and other stuff. So taking it to the next step of basically making this interactive was kind of like the obvious next step, but technically it's quite challenging, and especially in terms of how fast we should create the next frames, right? And that's basically that's what was one of the core challenges for the project for Genie 3. And I think the approach that we have overall is to try and understand how those models train, how they're being trained, how they learn, and the same kind of like principles that helped us scale and improve Veo, we found them to be useful for Genie 3 as well.
It seems to me, okay, as an outsider, right? It seems to me that the objective of Genie and Veo are, I mean, even though they look visually quite similar, the objectives of them are quite different, right? Like Veo, you're trying to create this very realistic, non-interactive environment, whereas with Genie, you need to make this consistent, explorable world that you can move around in. Do you have to start from scratch, or is there like kind of swaps that you can make?
So I think in a way, if you think about the video model, right, you can tell it, okay, I want to walk around maybe a volcano, or I want the camera to move that way or another. So what it does is basically looking at this entire video and tries to create a coherent 8-second or whatever a long video, and it can change the past and the future at the same time. I think that's the property of video models that is very different from Genie 3,
because it spits out the end result.
Exactly, and it can like, you can think of it like as a painting that you can change all the time, everything on the canvas, and while it's much in a way easier than doing it in what we call auto-regressive, or just like extending one frame at a time. So I think that's the fundamental difference. There's still a lot of similar aspects. For example, the way that we have eventually to take some text input and convert it to some kind of visual output. So that's somewhat similar. So I would say definitely we don't start from scratch. We build on top of, I think, a lot of work in this space, but there are definitely some novel properties that we had to kind of like figure out.
Well, that's super interesting, actually. The idea that like time is the key component in this, that you have to understand the past and march forward to the future. That's where the auto-regressive stuff comes in, right?
Exactly. So essentially, every frame you see is generated from scratch at that point in time. So things that happen later in the interaction aren't known yet, right? And things that happen at the beginning have to all be remembered by the model, right? So essentially, if we're doing 24 frames per second, it's like doing image generation 24 times per second, right? Each one completely generating from scratch, given all of the past and the actions of the agent or human player.
There's an analogy here, though. I mean, that's sort of the way that language models work, right?
Yes, exactly. So I think it's really a good example. So we know that language models are basically being trained to predict the next token or word, right? So they look at text and try to guess, okay, what's the distribution of words or tokens that happen to follow? And what we have with autoregressive word models, we actually have a similar problem. We want to basically predict the next observation, which is pretty much visual, the next frame, given what was already seen. And the nice thing, I think, in this kind of like parallel to LLMs is that LLMs learn from that very simple task a very rich potentially representation of the world, or how people think, how people solve problems, for example. And what I think the reason that word models, especially autoregressive models, are kind of like exciting for us is because maybe through that task, that is pretty much simple task that anyone can understand, they have to learn the dynamics of the world. And I think it's nice if you really think about it, like this is it's kind of like a superset of intelligence, because through the world, if you say, okay, now I'm playing chess with some grandmaster, and what's the next, the next visual or the next frame would actually be their next maybe move, right? So of course our model is not capable of doing that, but at the limit, it kind of goes very, very far.
But it's these ideas of understanding the past, the context, and being able to predict the next move in the future, which are all big parts.
Yeah, it's also quite powerful, right? Because it means you can start in the same location and do many very different things, right? So from an agent's perspective, there could even be quite a simple task, but you want to get really good at it. And so you can simulate various different scenarios. And this is very analogous to reinforcement learning paradigm, right? Where you have this env reset function that brings you back to the same state, and then you want to get more experience from there.
Well, let's inch through this then. So the very first frame, you can have an image like you did with the painting, but you can also have a text input, right?
Yes, of course.
I mean, I know you asked me earlier to describe somewhere I'd been, and I got to go to a hunter's lodge in Siberia once. It was sort of the most impressive thing I could come up with. And this is what I sent to you. I went to a hunter's lodge, sat on a reindeer skin in the woods outside of Yakutsk in Siberia, drank vodka and ate frozen calf liver.
Yes. So
tell me what you did with that.
So first we were surprised with the prompt, but then we just tried to, we put it into the system, and the system is basically able to add a few more details to the prompt that you provided, but still it does follow the key elements that you provide, right? So for example, I think it's reasonably, I'm not sure if it's a reindeer, but it's definitely is. So, and then here you can see the table.
That's really amazing. The light, again, you guys are you love making the light late afternoon, the beautiful golden hour.
You also missed the calf liver, and it's frozen too. Frozen calf liver. It's not even just calf liver.
That first frame then is generated in the same way as you might find in Veo.
Yes, so the model doesn't treat it like in any special way. It's just like you give it a text, and it just starts outputting frames, and it doesn't do any preparation before it. It just throws you into the world, and you can go wherever you want.
And then it's from that first frame that the prediction backwards and forwards.
Exactly, yeah. So it's like text to first frame, then first action to next frame, and so on and so forth from that point onwards, basically.
And how critical is the exact wording of the prompt here? I mean, can you get better images, better worlds with better prompts?
Yeah, I think that's definitely true. There's an art to prompting, I think, all of these modern models, right? And some people are better at it than others. Unfortunately, we have some people who are much better than me at this.
This one worked pretty much out of the box, right?
This one, yeah, often they work pretty well, especially when you have very vivid description, like the table with the vodka and the frozen calf liver. But sometimes you can try something and not quite capture exactly what you wanted first time, and then you can iterate a little bit on the prompt and then get something that's much more like what you wanted.
And does that require you to regenerate the world, or given that it's marching forwards, can you add things in on the fly?
So we do have ways to add things on the fly, what we call promptable word events. And this is just something that you can say, okay, now I want, for example, like a balloon to fly in, or some other character to show up. This is something we're very excited about, because it also allows the environment to be more interesting for people, but also, as we mentioned, kind of like more relevant for training agents in simulation, because then we can kind of throw in something that happens in the world that they have to adapt to.
So like in that example, maybe have a reindeer coming through.
Right. We can have a reindeer, or we can have like another person is walking into the scene, or and then we have to, like, if it's an agent, basically it can respond to it, and if it's just for kind of like entertainment purposes, then it's much more interesting than just walking in a world that's nothing happens.
And this is all a key advantage of the auto-regressive part, I guess, right? That you do have control over the future.
Exactly, yeah. So you can just inject things sort of on the fly as you're generating things in real time.
The thing that I find extraordinary about this is the consistency, right? Like the memory of the system. You turn away and then you turn back, and it's exactly how you left it. But presumably, if you're turning in a direction you haven't yet turned in, then it's sort of a stochastic process, right? So how do you balance it that it's sometimes a memory and sometimes generated statistically?
Well, it's kind of a mixture of things. So you can, in the text prompt, specify things that are out of sight, which I think is quite powerful compared to image prompting, right? Because you can say, on the right is X, Y, Z. And then when you actually look round to the right, it's there when you actually play or interact in the world. But then there is also an element of the model using its world knowledge to generate things. So in the Hopper example with the artwork, it does generate the street that we haven't seen before. And you can't be exactly certain what it's going to generate. The model uses its own sort of, I guess, intuition of what should be there.
And that's intuition based on, having watched, incredible amounts of video footage in advance.
So basically the model is trying to just generate a sequence of frames that is representative of the world, right? So if it already saw some part or generated some part of the world, then the right thing for the model to do would be to kind of like recall this memory and use it. So if I look back to where I've already been, then the right thing for the model to do would be just to use the same thing. But when you look to a new area, so from the model perspective, again, it can allow itself to generate something new because it hasn't been seen. So the model doesn't really treat it in a fundamentally different way. So the model kind of it learns to basically balance the two aspects. And again, all comes back to anchoring all of the generation to the prompt or what the user provided, right? That's where the information to the generation comes from.
But then I guess going back to the language analogy that we were talking about earlier, it's not that surprising that once a statement has been established in a conversation, that it remains consistent when you refer back to it.
Exactly, yeah. And we've seen with language models this like sort of ability to like have memory and consistency has been something that's improved a lot recently, right? Especially with the latest Gemini models now versus 2 years ago.
Yeah, I think what's interesting here is that while if you think about the number of like the size of the memory or the level of detail, so if we think about like I'm talking to Gemini and after a few sentences it might refer to something I've said before. That's great, but the number of details that we have in those visual words is just like it's staggering, right? The quality of the memory with considering how much detail and how much information it has to actually remember. Yeah.
Well, how do you do that? Does this require you having a sort of 3D representation of the world that you're in?
We don't use anything like that for this version of the model. It's largely just learned as an emergent property, just from this auto-regressive prediction.
You guys with your emergent properties, my goodness me.
Yeah.
we are very good students of the bitterless.
Yeah, I think it's similar to if you're predicting the next frame, you just have to learn to remember these critical things in the past. And obviously the model has some representations that prioritize the important details, but it really is just predicting the next frame.
And is this analogous then to the fact that language models have this conceptual understanding and can describe similar things or the same things in different ways? Is it the transformer architecture here that's allowing you to do that?
Yes, so the architecture is, I think almost everything today is a transformer. So yes, this is also based on a transformer. Looking back, basically the model will see what was already generated and including in the user provided inputs, and based on that makes the prediction. So I think the interesting question about explicit 3D is that the model probably had to learn some representation, but it's just not an explicit representation. So we see that the ability of the model to understand 3D environments is very strong. And I think the most, to me, like an emergent, if you want, a capability is that it actually works where it was not trained for, like, for example, in taking a painting, an oil painting in 1942, and actually making it into some kind of a 3D environment. That's pretty much out of its distribution.
Absolutely. I want to go back to this idea of it understanding physics. Jack, if you've got this world that you can put an agent in, does that mean that you can test how well it knows physics? I mean, could you get a hammer and a feather, for instance, and allow it to drop it at the same time?
You definitely could do that. I think that would probably be close to the frontier of the model's capabilities at this point. We've seen it's quite good at visual things and things that are more general concepts, right? So you can imagine water occurs in quite a lot of different scenarios it's seen before. Gravity has probably occurred in many of those, but probably not these exact objects. But I think if you were to specify in the text prompt, like in the world there is a feather that has less gravity and a hammer that is heavier, maybe then it would work.
Yeah, I think there are a lot of like those models are inherently visual, right? They don't know anything about the world except for what we can see. And that's a limitation, I would say, right? Even for video models, some things sometimes don't make sense. And the model has to guess if something's heavy, for example, right? There is no real way for a model to look at an image and say, okay, that's how much this thing weighs. So it kind of like makes up the weight and then try to kind of simulate what would have happened. And sometimes it breaks, and we know that from video models, even the best video models. And I think what we have is basically we're solving an even harder problem, because we have to, as we said, like not just, we can't fix the past, right? We have to like go, if once the model generates something, it has to roll with it. Like, I think we have really good progress in terms of simulation, like fluid dynamics, but maybe some other aspects of the world physically would not be accurate because of those limitations.
Well, tell me some of the work that you've been doing with agents so far, because actually on a previous episode we got to talk about SIMA, the scalable, instructable, multi-world agent,
Exactly,
which they were putting into existing computer game environments. But I mean, you can now take SIMA and put it into these generated environments too.
Exactly. So the cool thing with this is that we've got at Google DeepMind, we have these agents that are trained to be general, right? The M is multi-world, as you just said. And so what we're able to do is take the worlds we generate and then test whether these agents and the latest versions of them are able to already use them for agent training or collecting experiences or evaluations as they are. So you can say to it something like, navigate to the robot over there. And then you can give it like an image from the world, and it can take the first action. And then from that point onwards, it's interacting in the world through actions. But the Genie 3 model does not know what the goal is, right? So that makes it like a genuine simulation, rather than if you were to tell Genie 3 the goal that SIMA agent is trying to achieve this goal, it might make the experience not authentic, right? Because it might make it happen in an incorrect way.
For it.
Yeah, exactly.
I guess if you've got a robot in the real world, the world isn't helping the robot.
Exactly. Like you can't say, okay, the robot has to go to fetch the red cube, and then it looks to the left and there is a red cube, right? It's a bit making it.
Yeah, and this is a problem that we've encountered in other scenarios, but you don't really get this problem if you have this separation between the agent and the environment. And that's the really nice thing of working with agent teams that are focused on building really capable agents, but then having them access our environment as if it's any other environment, right? So the new worlds that are created by Genie 3 look the same as the existing worlds that the SIMA agent was trained on.
But then what if there isn't a red cube? What if it searches around forever and there is no red cube?
So I think that's part of the things that we're looking into, is how we can add more details as we go, right? Like, for example, if you put the agent in some room and then it has to open maybe a drawer and find something in there, right? So we want to be able to inject kind of like events into the world and control it. So I think this is kind of like the interesting frontier here, is how you can make the world look very realistic, and also control what's happening in the world in a way that is still makes sense. So I think what we've seen is that with our promptable world events, we can add things that happen in the world. But if you just want something to pop into the world, then it's not necessarily a plausible thing. Like if you look at, I don't know, if you're in the desert and then you're going to ask it, okay, now I want to see an elephant, then where does this elephant going to come from? So maybe it's going to come from the side, or when you look to the left. So I think there is something really interesting in what does it mean to change a world, because the model has some assumptions. And when it comes to agents, this is definitely an important capability to be able to inject this new event into the world.
So you've done this already?
Yeah, we've got signs of life for this. I think we haven't really we've got a full agent training loop where we're already doing some like large scale training in these environments. But what we can already do is test the agents in them and see how they do, right? And I think it's quite remarkable that given these things weren't developed together, we just drop the agent in and it can already do things. And you can imagine all the different things you could now use this for.
Color that in for me. Give me an example.
If you have like a factory where you have some robots and you want to introduce maybe a new, like maybe a very boring example, but a new machine, right? And that wasn't there. Or you change somehow the structure of the building and you want to test the robot before you actually put them in the new building, right? So again, this is like you can simulate the world that's basically is a variant of what the model, maybe the agent has seen in the past, and see if it breaks. And right, and everything can happen in like simulated environment, and not necessarily break your new machine, right? So that's like one example, I would say.
Find the unintended consequences.
Yeah. And evaluation of the model. So that's even not training a model, like the agent, just testing how well it adapts maybe to a new variation of an environment.
All of these examples you've given so far are where the agent has a specified objective, which I know is like sort of the point of SIMA thus far. But what about if you had agents that didn't have an objective? There was a really nice quote that I came across, which is that almost no prerequisite to any major invention was made with that invention in mind. Can you imagine a point in the future where you are letting agents loose in these environments without specifying an objective for them?
Yeah, exactly. So the quote comes from Why Greatness Cannot Be Planned, which is from Ken Stanley and Joel Lehman. It's a great book. And the general idea there is that searching for interestingness might actually lead to things that are more useful for practical goals than if you just directly optimize for the practical goals themselves, right? And clearly, the bigger the domain and the space for discovery, the more interesting things could happen. So they had this really nice example quite a while ago with this paper called Pick Breeder, where essentially they allowed people to select images and sort of combine them to create new images that were mutations of those two. People weren't directly optimizing for specific end goals, but by just choosing what they found interesting, they ended up discovering really cool structured pictures like a skull or a butterfly that weren't obvious how you would reach that from the starting points. And some of the stepping stones along the way didn't really look much like the final goal. And they wouldn't have been things you obviously would have chosen to go for if you had those goals in mind. And there are lots of examples of this in the real world. If you are, for example, trying to reach the moon, you wouldn't build a bigger ladder, right? So optimizing along one dimension with maybe like a greedy, myopic approach doesn't always lead you to make these big leaps.
Well, I mean, evolution itself, right, is like the classic example of like iteration without objective.
Mm-hmm. Yeah, and we see this a lot in research.
Yeah, my perspective on that is that I think we as humans, we kind of decide what's interesting. I think there is even an example where the entire evolution of mathematics was guided by people deciding what's next, what's interesting, what's not interesting. And just the problem being hard doesn't mean that it's interesting at all, right? And I think in a way, when we think about generating new things in science, it's like the goal, or like it doesn't have to be a goal, but there is some aspects of maybe beauty or interest that is coming from us, and models might maybe learn to simulate that. But I think it's really important to remember that we ultimately decide what's interesting as kind of like our preferences as people.
I mean, you haven't had the move 37, as it were, in this domain.
Even in this case, right? Like the goal of Go or the game was designed in a certain way that people find it interesting to play, right? Otherwise, and it's a very ancient game, right? So I'm just saying that the setup, even when there is or getting to the moon, this goal was kind of like maybe made by people. So I'm just saying, like, I think there is still a broader constraints set by us in a way, and like if a machine comes up with a problem to solve, we still have to say, is this an interesting problem? Because otherwise we're just like, okay, I don't care about that. So I think there is still an aesthetic part to anything that's open-ended to me.
Yeah, I think there was this quote from Demis a while ago about the levels of creativity. And it was like interpolation is one, like you see a new cat and you can identify it as a cat. Extrapolation was one where it's like, given the rules of Go, can you discover a new move like move 37? And then the third level is generating completely new things. So like, could you actually invent Go, is what he said. And we actually had this as like a motivation for the Genie project at the beginning. It was like, can create completely new things? And I think we're starting to see that happen. Since it's a completely new kind of model, right? Someone on the team will do something like create a certain kind of world, and then immediately other members of the team are like, that's really interesting. And then they start sort of evolving that idea themselves. And then we post it on social media and we see the reaction to some things, and then we know that's interesting. So then we create new things that way. And that's just with a very limited access to the model. So clearly you can see if we open this up a bit more in the future that it could lead to some sort of like open-ended creativity that way.
It's kind of like that, but still the evolution is like an evolution with the criteria that people find it
Yeah,
interesting,
exactly.
right?
There's people in the loop guiding the like
Yeah.
interestingness.
Well, then, okay, could you take, I'm just thinking back to the conversation that we had with Dave Silver earlier in this series, where he was sort of saying, you know, actually, there's one way you remove humans from the equation and actually you get even more surprising results potentially. Could you, okay, just play along with me here for a moment, but could you get to a point where you just simulate the first, I don't know, single-celled organism and allow it to evolve inside of Genie, or, you know, and actually watch the process of evolution happen in a virtual environment?
That's a great question. And that's kind of the dream of like an A-life open-ended evolution community. I think maybe the worlds that we create are not fully rich enough, but I definitely think that we're getting along that path, right? So open-ended evolution and A-life, they've been designing worlds that could facilitate this kind of thing, typically in code. And so this could be an alternative approach to getting maybe richer real-world simulations. And so in theory, I mean, we've been made quite a lot of progress pretty fast. But if you got the simulation to be fully like the real world and it had the kind of objectives and constraints that lead to these kind of evolutionary steps, then it's definitely plausible. But I can't say it's definitely there yet.
It's not a direct answer, but I actually tried. I think like there is maybe a very basic example of like, you know, game of life, you know, right? So it has
John
four.
Conway's,
It has 4 rules, right? And then I actually tried using Veo to simulate it, right? You give it an image and it doesn't work. Like it does look like it's evolving, and if you don't know the rules, you would look like, yeah, it looks like reasonable, like different pixels light up but it doesn't follow the 4 rules of the game, right? I think this is a good example for what our current like models are able to do and what they are less like still limited in their ability to follow specific rules. To actually evolve maybe life forms, I think you need much more kind of like ability to do both, to also simulate the physical world, but also kind of like follow some basic rules of physics in a very kind of like accurate way.
Constrained way.
And yes, and constrained way. And I think we're not like, we see some glimpse of it, but it's definitely very far from being able to have evolution on a GPU.
Well, thank you for going philosophical with me for a moment there.
I
enjoyed that. Let's come back down to earth with a thump though, because I mean there are safety implications with this. What are your main concerns?
I think there's different levels of concern, right? There's sort of the known things, and they're quite obvious. I mean, things like violence, maybe we wouldn't want to occur in the world in new ways. And that's something that we can already start addressing. But there's also maybe some more gray areas where we're not actually really sure how we feel about these things, like historical settings, for instance. Some of them may be unsavory for subtle reasons. And those are just things that we as a team can see quite clearly. But I think there's probably also some things that we haven't considered, right? And we'd rather get those things right by limiting our early access and getting feedback, which we're already doing. And we've already learned a lot from the folks that we brought in a few weeks ago and the folks that we're still interacting with.
Like what?
We found out a lot of new use cases that I didn't think of. Vocational training could actually be quite impactful, right? Lots of people can't go into the role of things like firefighting, for instance. What does it feel like to actually be there without having a visceral like sort of experience? It's probably something that you would benefit a lot from to be able to simulate in advance. Even if it's not perfectly correct from a simulation perspective, there may be elements to it that just getting a sense of what it's like to be situated in that specific circumstance, that it's quite nice to be able to simulate in advance.
Minus the heat.
Yeah. Minus the heat and the smoke.
and the genuine jeopardy.
Yeah.
Yes. But actually, you raised another interesting point there, though, because you said even if it's not perfectly realistic, is there also another danger about this gap between what's simulated and what's real? How do you make that as small as possible? This is something, the sim to real gap is something we've spoken about in this podcast lots of times before. Let's say you've got your example where you've got a robot in a factory. And it's moving around, it's sort of
in terms of reliability,
interacting. You can't directly take that and map it onto the real world, right?
Yeah, so I think over time we'll see more control being able to take maybe a real environment, map it into the model, so the model can base its generation on the real environment, and we see it to an extent. We're starting from an image or starting from a video. And now the question is, would it be perfectly the same as the real world? Probably not. I don't think it's even well defined. What does it mean? But I think the gap is definitely narrowing. So we can take environments. If the past we know a lot of the RL environments look very far from anything that's photorealistic or real world. But now we can go it even closer. So, but definitely there still remains a gap, and we will have to kind of see what are the implications. And like we're still not using it for any real world deployment, of course. Yeah.
Yeah, I think it's kind of an iterative approach. I don't think we're saying right now we've got Genie 3, we've solved simulation for any possible embodied task. But I think what we can do is sort of combine it with other techniques. So we still would train our agents in the same way that we already did without this, and we use it to kind of augment the training process. And then another element to it is it's really important that it has some diversity, right? So if it's always wrong in the same way, then agents might learn to exploit that inaccuracy. Whereas if the model can generate quite diverse sort of different worlds, then what we can do is really test the breadth of the agent's capabilities and make sure that there's no scenario where it does something really wrong. That might actually be a strength, right? So same in sim to real, we want to do domain randomization. Maybe by having a model that is a generative model, being able to sort of search the space of possibilities and check that all of them, the agents do something sensible, might be a good thing. But that doesn't mean you want to completely train it that is the real world. Maybe you want to use it to make it more adversarially robust rather than learn specifics.
Let me make sure I understand that then. So if it's wrong, but wrong in unpredictable ways, then actually that might end up making the agent more robust in the long run.
Yeah, so what you want to do is similar to domain randomization, is you want to make sure that there's no plausible scenario where the agent could do something really unsafe. It's quite a different objective than if you had one specifically incorrect scenario and then you told the agent exactly how to behave from that one. Instead, it's sort of make it so that in any possible future world, the agent should be able to do something sensible.
That's so interesting then, because I was sort of imagining that you were trying to kind of nudge this towards it being more realistic, towards getting like more reliable outcomes, towards sort of like closing that gap of sim to real. But I mean, the way you're describing this is that not necessarily.
I think the question is what do you mean by reliable? Because reliable to me is that is probably a lot about following the instructions that we provide, right? The model. So if we want the model to simulate a specific environment and we describe it with a lot of detail, we want the model to follow that. If there is something not so plausible in this description, the models should still follow that. And I think the challenge is that sometimes we as people, or like for various reasons, we're interested in the less plausible scenarios, right? We're just looking at the tree or in the middle of, like, for example, in some of the examples we saw today, you wanted some vodka and the calf liver, all right? So that's not a very, it's not like if you just sample from all of the possible tables in Siberia, probably that's not like, in the middle of the distribution. So I think that the reliability to me comes mostly from following the description that we provide the model with and simulating the world in a way that would be close to that.
I think that's a really good point, actually. I think it's in underspecified environments, you want diversity because you want to be able to adapt to anything within the plausible distribution. But if you have a very well-specified environment, then you want it to be accurate. And I think we're kind of seeing improvement on both those dimensions, but we're probably not fully there yet.
Let me go back to that AGI question. How if I may, the end question that everyone always wants to ask, do you think that this is a step towards it, Jack?
I think AGI is something itself which is relatively subjective, and people have different interpretations of what you mean by AGI. So I think it would be quite maybe grandiose to say our model is the key thing in the whole field that will enable AGI. But I think for me, an AGI needs to be embodied and be able to act in the physical world. That's what really excites me. I think that could really improve people's quality of life in any demographic anywhere in the world. And so with that framing, I definitely think this is an important tool. I can't see how an embodied AGI or an AGI that is embodied would be able to operate in any scenario in the world without being able to simulate it, to gather experience and learn from its own experience. Because that's the paradigm that we've used in other settings to get superhuman capabilities or even just robust capabilities. And so I believe very strongly that we need simulation. And I also believe very strongly that we won't be able to build a simulator of the real world any other way. So when you combine those two things, I think, yes, it is a big step for my version of AGI.
Yeah, and I think it's really good answer. And on top of that, I would just say that our current generation of AI is limited to kind of like the digital world. For AI to be useful for us, definitely it has to have some kind of a real world interaction. So I think again, it's a small step towards that embodied AI. And there are definitely a lot of gaps to get there. So I think we need much more better signals for, like, for example, robots get while they walk through the worlds, right? They need to get some physical response. It's not enough just to have a visual input and output. So I just think that this is definitely a step towards that vision, yeah.
Because there is still a lot that this can't do. I mean,
yes.
the additional sensors being one of them, but also doesn't handle people that well at the moment, does it, Jack?
Exactly. And I think that's really the key thing, is I both think this is one of the most promising technologies to achieve sort of sociable and socially aware robots and embodied agents. But also I think that's the biggest limitation probably of the current iteration of the model, is that it doesn't do this perfectly, right? Because our standards have raised, and that's the thing that we now think is something that isn't good enough. But I think it's really critical that we do have that, right? Because even if our robots and embodied agents fully understand physics, I think physics are fairly consistent around the world, but people are not, right? And we want these agents, robots, whatever form factor they come in, to be able to really augment humans and work with humans to make our quality of life better. And so they need to understand how humans think, work, interact, and be able to work with us on things. And so that's what I think we're really excited about as one of the things this might be enabled by our model.
Yeah, I think there are definitely a lot of limitations that are in terms of the quality of the generation. But what I'm mostly, I'm very excited about the pace. You know, if we think about it, like we had Genie 2, Veo 2 in December, we definitely feel the pace, the impact on it in our personal lives. But the field is just moving fast. And if we remember just less than 2 years ago, we had images generated with 6, fingers. And that was a big thing, and nobody's speaking about that anymore. So I don't see why won't be able to generate people in much higher fidelity, and with everything that follows that.
Is the goal here then to have a foundational model to essentially do for simulated worlds what LLMs have done for language?
Yeah, exactly. I think you put it better than probably than I could. I think this is really a step change as a foundation model in terms of the breadth and generality and capabilities. And I think this is probably similar to sort of what Shlomi alluded to, as we've seen with images recently, where there were things obviously like the fingers to them now being, pretty incredible. We saw the same thing with video maybe in the past year, where once we had something like Veo 2, it's looking pretty amazing at this point. And we saw this with language models maybe 3 or 4 years ago, where they started to get really capable. And we wanted to get to that point for this new kind of foundation model, sort of an auto-regressive world model. Now we're there. There's a whole host of different potential things it could be used for and have impact on. And we're still fairly early in that right now.
But are there elements of simulation too, right? Like, do you think that you will ever be able to use this kind of idea to recreate a lived experience rather than just a visual one?
So we have many senses that we're not even aware of, right? Like, so for example, proprioceptive reception, that we are basically, we feel where we are, and we have this kind of like notion of where we are in the world. And I think this is when we think about actually putting people in a simulation to really feel kind of immersed in it. I think this is a huge part of it. And basically the constraint to visual and maybe audio is still too much of a constraint. I think there is definitely a potential for that, but it goes through multiple technologies that we have to build that to actually get there. So before that, I expect people to be able to kind of interact with photorealistic environments, but still in through some kind of an interface that will be like a hybrid interface, that maybe they can feel some sensation through like maybe gloves or something.
I think I would also say that there is definitely something about being interactive in real time that does make a big difference for the experience. And we've had members of the team say that they visited childhood locations, for example, and did actually get like a sense for it that you couldn't really get from an image or a video. So there is already some sort of a degree of experience that you can gain from this kind of model already. And obviously we're working hard to make it an even more capable model in the future. So maybe that will extend.
Yeah, there is actually, it reminds me of a project that we had earlier in the year that the team at Google used Veo actually to help people with onset of dementia to go back to their childhood memories and reconstruct them. So I can imagine that might be, for example, potentially therapeutic tool as well, that they can not only look at the video, but maybe actually relive or remember some things that's from their childhood. So I think that even before, we don't need to go very far for things to have positive impact on the world. Yeah.
Amazing. That was absolutely fascinating. Thank you so much.
Thanks for having us.
Thanks for having us, Hannah.
I think the most impressive part of this is not what you're looking at on the screen. It's how that is generated. It's this change that this model represents from creating realistic images or videos of the real world as though they were frozen moments in time into something that can actually handle time in the way that we experience it, with an arrow that's pointing in only one direction, right? Where effect follows cause, to build this consistent, forward-moving world where the present is a direct result of the past. And that is why I think that this is an early hint of something that's much bigger. This is not just a new way to design games or beautiful environments. This here is the bedrock for machines that can genuinely plan and reason about our world. You have been listening to Google DeepMind, the podcast, with me, Professor Hannah Fry. Now, we're going to take a little bit of a pause over the summer, but we're going to be back with more episodes in the autumn from Google HQ in California. And in the meantime, do take a look at our extensive back catalogue, which covers everything from tools for creators to AI for drug discovery. See you soon.